In this video, I am going to solve a system of linear equations using the Kramer's rule. We are given a matrix A, which is a 3 by 3 matrix, and matrix B, which is 3 by 1 matrix of x, y, and z, and matrix C, which is a 3 by 1 matrix. We need to solve the system AB is equal to C. Okay, so this is how we will solve it. We need to first find the matrix AB and set it equal to matrix C. So we are just going to do straightforward matrix multiplication. So if we do that, first row, first column is going to give me the following. 1 times x is x, plus 4 times y is 4y, plus 2 times z is 2z, is equal to 2, which is going to be this first entry. Now in exactly the same way, we are going to do it for the second row. 4 times x is 4x, plus 0 times y is 0, plus 3 times z is 3z, that is going to be equal to 5. And then from the third row, we get 2 times x is 2x, plus 3 times y is 3y, and then 2 times z is 2z, that is equal to 4. By the way, this is my system of linear equations that I am going to solve using the Kramer's rule. The process is very standard. First, we need to find the determinant of the matrix A, and we need to make sure that that determinant is not equal to 0. If we just follow the standard process for expanding and finding the determinant, this is what we get. So in my case, I have expanded it along the first row. 1 times 0 minus 9, so I ignore the first column and the first row. That gives me the matrix 0, 3, 3, 2. So the determinant of that is going to be 0 times 2 is 2, minus 3 times 3 is 9. So that's exactly what I have. Then for the second column, first row entry is going to be negative, so negative 4 times, if we ignore the first row, second column, we get 4, 3, and then 2, 2. So determinant of that is going to be 8 minus 6. 4 times 2 is 8. 8 minus 3 times 2 is 6. This one. And finally, first row, third column. If we get rid of the first row and the third column, we'll be left with 4, 0, 2, 3, 4, 0, 2, 3. And the determinant of that is going to be 4 times 3 is 12, minus 2 times 0 is 0, which is this one. And if we simplify it, we get 7, which, by the way, is not equal to 0. So that means that we have a unique solution. So that's one of the conditions. You need to make sure that the determinant is not equal to 0. Now I'm going to find a matrix which I'm going to call D sub x, okay? Which, by the way, I'm going to take the given matrix A and replace the first column, okay, or the x column by 2, 5, 4, this number. So if I do that, look, this is what I'm going to get, 2, 5, 4 in the first column, and the second and the third column stays the same. It's going to be 4, 0, 3, 2, 3, 2. So that's what it is going to be. Now I'm going to find the determinant of D sub x. Determinant of D sub x, which, by the way, is going to be this. Exactly the same way we did it here, we are going to do it here. So it's going to be 2 times 0 times 2 is 0, minus 9, then minus 4 times, so I'm expanding along the first row, is going to be first row, second column, if we ignore that, is going to give us 10, 5 times 2 is 10, minus 3 times 4 is 12, then plus 2 times, so this column and first row we ignore, is going to give us 5 times 3, 15, minus 4 times 0 is 0. If I simplify it, we get the following. So the determinant of D sub x, is going to be 20. Now to find the x value of the solution set, remember there will be three values, x value, y value, and z value. To find the x value of the solution set, we are going to take x is equal to determinant of d sub x divided by the determinant of a. Okay, determinant of a, which in our case is very straightforward, is going to be determinant of d sub x is 20, determinant of a is 7. So my x is going to be 20 over 7. Now in exactly the same way, we are going to find y and z. Now when we are finding the values of y and z, remember we have to replace the second column which corresponds to the y coefficients and replace it by 2, 5, 4. If we do that, we get the following. So let's look at d sub y. I just took the given matrix A and replaced this middle column, which is the coefficient of the y terms, with the C matrix, which is 2, 5, and 4. Then in exactly the same way, I have found the determinant of y, right? So determinant of y is 6. So my y solution is going to be determinant of d sub y divided by determinant of a. Determinant of d sub y we found to be 6, right? Divided by determinant of a is 7. So my y is equal to 6 over 7. So let me just put a box around it and put a box around it so that you know. Now we are going to find the z value. Now of course we are going to replace the third column in the matrix A by the matrix C, which is 2, 5, 4. If we do that, we get the following. So the determinant of d sub z is negative 15. Now my z solution is going to be z is equal to determinant of d sub z divided by determinant of a. Now determinant of d sub z is negative 15, right? And determinant of a is 7. So my z is going to be negative 15 over 7. So I found x, I found y, and I found z. So my solution set for this system of linear equations is going to be x comma y comma z is equal to 20 over 7 comma 6 over 7 comma negative 15 over 7. Now let me go ahead and summarize what I did. We were given a system of linear equations and this is the system we found. Now first we find the determinant of the matrix A, coefficient matrix, okay? If that is not equal to 0, then the unique solution does exist, okay? In our case, the determinant of A or the determinant of the coefficient matrix was 7 and that's not equal to 0, so it works. Now we are going to create a matrix by replacing the first column by the matrix C, which is 2, 5, 4, and we call this matrix D sub x. So look, I replace the first column by C, which is 2, 5, 4. Now remember here the first column corresponds to the coefficients of the x, okay? So the x coefficients are being replaced by the C constant, right? So now D sub x is going to be this matrix. We are going to find the determinant of D sub x, and we do so. And once we find the determinant of D sub x, to find the solution x, we take the determinant of D sub x and divide it by D sub a. I mean determinant of a. And then we get 20 over 7 because determinant of D sub x is 20 and determinant of a is 7. Now in exactly the same way, we do the same thing for y. Replace the y coefficients in the A matrix by constant C and then find D sub y and do the determinant of D sub y and then divide it by determinant of A to get the y solution, and Then the same thing for z. Replace the z coefficients in the A matrix or given matrix A by the constant c, which is 254, and then we call it d sub z and find the determinant of d sub z, and then take that value and divide it by determinant of A to get the solution for z. And finally, we get the solutions x, y, and z. By the way, this is a very standard process for using Kramer's rule, and you should be able to solve any system of linear equations using Kramer's rule. I hope that this discussion was helpful. Thank you very much.